is to provide an alternative analysis to a potentiometer. This is the most general case where all the parameters are same. E is the driver cell, R is the internal resistance, RH is my rheostat resistance, and this is the unknown EMF I wish to determine, and RE is the internal resistance of that cell. Now suppose my galvanometer, I am performing the experiment, I have started from A and let my galvanometers and J be at some distance x from A. Now this is not a balanced condition, so I will say that there is some current in the galvanometer. So I am trying to analyze what happens if I am not at the balanced condition. So let me take the current in this loop to be some Ig, because this Ig is the current through the galvanometer. So I am just considering this Ig to be in this manner. Now this is current I. This current I is the current in the primary circuit in this FE branch. So this I is coming this way. At A, Ig current flows through this and I minus Ig is going that way. Now what will happen at J? This Ig current will go here and again I will get back I current. So this I current again comes at through J and it again goes through this EF and so on. Now let RAB be the resistance in this AB wire. RAB is the resistance of the potentiometer wire. L is the length of the wire in meters. Now please be careful here. Now resistance in AJ portion. Now if I say RAB is the total resistance in the entire length, so resistance in AJ portion will be resistance per unit length into this X. Similarly, resistance in J to B portion. Now if this is X, this part will be L minus X. So resistance in J to B portion will be RAB by L into L minus X. Now this is the overall idea. Now what happens in the balanced condition? Let us see that also. Now at balanced condition level, this I current will flow entirely through this AB also. Why? Because there is no current in Ig. So there is no distribution now, I minus Ig. So at balanced condition, this entire AB flows, the entire AB has current branch I. Now this Ig is 0, so current through AC is also 0, CD and DJ is also 0. We have already learned this part. And then how did we do problems? We determined if I is the current, what will be the potential gradient. If you remember, this was the concept, right? Current through this is 0, I flows through AB. Now I will say potential gradient phi will be VAB by L. And how is VAB evaluated? I into RAB by L. So just recall all this, right? Now coming back to this part. Now let's say I am not at the balanced condition and I am at some X, right? Now I will apply some loop law to ACDJ. ACDJA. I am applying the loop law. So I will go to A to C. There is no potential drop, assuming, right? This resistance is not that much. Now plus to negative. So plus E plus Ig into R of internal resistance plus, right? Then here it will go and here I will get J to A. Current is this way, I am moving from J to A. So minus I minus Ig. What is the resistance of this portion? Total resistance of the wire per unit length into the X part. So RAB by L into X, this is equal to 0. Now if you arrange all this, you will get E minus I into RAB by L into X plus Ig into whatever is remaining. You collect all these together and that is equal to 0. You make it equation 1. Again you apply the loop law to FABEA. Now again F to A, nothing is there. Now A to J, right? A to J is a part of A to B. So A to J, I minus Ig, RAB by L into X. This much is the resistance in this AJ portion. Plus RAB. Now please be careful. I is the current in J to B. How much is the resistance? RAB by L, resistance per unit length, into length of this portion, that is L minus X. Plus I into RH plus I into R minus E equal to 0. Minus E is equal to 0. Now you collect all I terms together, Ig terms together and take this E that side. So you will get I RAB by L into X plus RAB by L, L minus X plus RH plus R. We are taking I common. Minus Ig into RAB by L into X equal to E. Now yes. So finally you will get, now be careful here, RAB by L into X, So you will get here minus RAB by L into X. So these two will cancel out here. Once again, RAB by L into X, and there is a minus RAB by L into X. So these two will cancel. So in short, you will get I RAB plus RH plus R. So RAB by L into L will make it RAB. This L into L will make it RAB. You will have RH and you have R. Minus IG into RAB by L into X is equal to E. Now suppose, now see, this part is where it is interesting. Now suppose at X equal to some L, I get a balance point. Now I have moved here to here to here. At some X equal to L, I get IG is 0. Now what will be the total current in A to B? I. So you substitute Ig equal to 0 in equation 2. So you will get I RAB plus RH plus R. See, this part is 0. This part is 0. This part is 0. So you will get this is equal to E. So how much will be I? E by RAB plus RH plus R. Recall, we did this, right? I told you during the derivation. How much will be the I? E by RAB plus RH plus R. Now from equation 1, what will I get? Again this Ig will be 0. So you will get I RAB by L into how much? This is now X. X is L. So minus this equal to 0. So you will get E equal to I RAB by capital L into L. Now just pay attention here. Now I'll take I RAB by L together. I RAB by L together into L. Now what is I RAB by L? Recall, it is nothing but VAB by L. I into RAB by L is VAB by L. What is I? I was the current which was flowing. Now since Ig is 0, the entire I is flowing this way. Now I into RAB by L into L. I is how much? E by RAB plus RH plus R into RAB by L. That into L. Now this entire thing is phi. This entire thing is phi. So recall, E by RAB plus RH plus R into RAB by L. This is phi. So this E equal to phi into L. Now I hope this is also clear to you. So this is the most general. So in fact, if you face tricky questions like if they ask you how much will be the current when it is not at balanced condition, you can simply apply Kirchhoff's law. So these two equations will come in handy. Okay.